Hello everyone. Today we'll be looking at the quick solutions to the chemistry section of All India AIATS Test Series JEE Advanced 2020 Test 2A Paper 1 Code C&D. So let's start with the first section, students. So students, the first section contains 6 questions. Each question has 4 options, out of which only one single option is correct. Okay. So let's start with question number 21. It says, which of the following drug or a chemical compound contains a phenolic group? Okay. So if you look at the options which are given to us, students, we've been given heroin, paracetamol, penicillin and chloramphenicol. So if we talk about the structure of paracetamol, students, the structure of paracetamol, it contains a benzene ring, an OH group and an acetylated amine group. Okay. So for question number 21, students, we have to mark the correct answer as option B, which says paracetamol. Okay. Let us look at the next question, students. Question number 22. The two strands of a double helical DNA are associated by hydrogen bonds between the nitrogen containing heterocyclic compounds called bases. Which of the following option correctly contains the bases which get paired in a double helical DNA structure with the number of hydrogen bonds between the nitrogen bases? Okay. So if we talk about the DNA, students, in DNA we have adenine bonded to thymine. So there are 2 hydrogen bonds between them, and then we have cytosine bonded to guanine. Okay, so there are 3 hydrogen bonds between them. Okay, so if you look at the options which are given to us, students, we can clearly see that for this question we have to mark the correct answer as option A. Okay, let us look at the next question now. Question number 23. The nucleophilic substitution reaction of the following haloalkanes is carried out with NaSCH3 in DMF. Okay, so students, the examiner seems to be interested in the SN2 mechanism, looking at the strength of the nucleophile and the polar aprotic solvent which the examiner has taken in the reaction. Okay, so 4 different substrates have been given to us. We have to comment on the correct order of the nucleophilic substitution reaction in the given conditions. Okay, students, if we look at the options which are given to us, we can clearly see that out of these given options, the third species is going to be the most reactive. Okay, so the third species is going to be most reactive because of the presence of oxygen. Now if we compare the other 3, which is the 1, the 2 and the 4, so benzyl chloride is more reactive than the allyl chloride, which is slightly more reactive. So benzyl will be a little more reactive than the allyl chloride, and then if we talk about the propyl chloride, it will have the least reactivity. So the benzyl and the allyl, they have a greater reactivity in SN2 reactions with respect to the normal alkyl halides because of the pi conjugation of the benzene and the allyl group present. So students, we have the correct order of reactivity. So if you look at the options which are given to us, we can clearly see that for this question we have to mark the correct answer as option B. Let us look at the next question now. Question number 24. Which of the following ester will undergo alkaline hydrolysis most easily? Students, we have to compare the reactivity of these esters. So the groups which are attached at the alpha carbon of the ester groups are different. So we have a Cl, we have a nitro group, we have a hydrogen to be compared with the nitro and the Cl in this case, and we have an OCH3 group. So students, if we talk about these groups which are given to us, we know that as the electron withdrawing nature increases, okay, the rate of hydrolysis will increase, because electron withdrawing nature, it increases the electrophilicity of the carbonyl carbon. So electrophilicity increases. So students, we know that the most reactive among these given esters is going to be the one which has a nitro group attached to it, because it exerts the greatest minus I effect as compared to the other groups which are given to us. Okay, so students, for question number 24 we have to mark the correct answer as option B. Let us look at the next question now. Question number 25. Consider the following compounds. So we've been given 4 different compounds, and the examiner seems to be interested in the compounds which are aromatic. So if we talk about the first compound which is given to us, students, we have a total of 4 pi electrons in conjugation. The boron, it has a vacant p orbital. So there is complete conjugation, but there is only 4 pi electrons in the conjugation. So according to Huckel's rule, this is not going to be aromatic, students. If we talk about the second compound now, so we have 6 pi electrons in conjugation with the vacant orbital of the boron. So students, this contains 6 pi electrons in complete conjugation. So this is aromatic, students. If we talk about the third compound now, so in the third compound again we have a lone pair over nitrogen. So it contains 8 pi electrons. So this is not aromatic. Okay, and if we talk about the last one now, in the last one also, students, there are lone pairs present over nitrogen. So a total of 8 pi electrons are present. So this is also not aromatic. Okay, so out of these given compounds, students, we can clearly see that only the second compound satisfy the Huckel's rule for aromaticity, and as a result only the second compound is going to be aromatic. Okay, so for question number 25, students, we have to mark the correct answer as option B. Okay, let us look at the next question now. Question number 26. 4-pentenoic acid is first treated with I2 and then with aqueous NaHCO3. The product obtained is. Students, if we talk about the structure of 4-pentenoic acid, we can first draw the structure, students. So we have 4-pentenoic acid. If we talk about its reaction with I2, so the I2 will first attack the double bond and form a cyclic iodonium ion. Okay. Now, students, it is allowed to react with aqueous NaHCO3. So the aqueous NaHCO3 is a base. It will extract the acidic hydrogen present in the carboxylic acid, leading to the generation of the carboxylate anion. So students, we're going to have the formation of the structure, students. Now this carboxylate anion will attack intramolecularly. So there are two possibilities of attack, students, but since the 3-membered ring already contains the cation, students, so this negative charge will attack that carbon which is more substituted. Okay, so this reaction is SN1 type, and the carboxylate anion will attack at this position as indicated, which will lead to the formation of a 5-membered ring. So we're going to have the formation of a 5-membered ester along with the presence of a CH2I as indicated. Okay, so if you look at the options which are given to us, students, we can clearly see that for question number 26, we have to mark the correct answer as option D. Let us look at the next section now.